This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you for joining us for the Satellite Book Club Seminar Series, session number 19. Hope you're staying well. Today, we're going to have a great presentation from Dr. Mike Pavolonis, who's a physical scientist at NESDIS STAR, and he's going to be presenting on recent developments of the NOAA CIMSS ProbSevere model. Glad for Mike to be able to join us today. He's been a longtime colleague of mine and always has great operationally relevant information to share. Just a few reminders before we get started that this session is being recorded, so you will be able to share it with your colleagues that are missing today because of shift work or for other reasons. We'll have opportunity for Q&A after the presentation, but be easier if you would post your questions ahead of time in the chat, and if it's a long question, we can work to unmute you and hear you that way. The post-presentation discussion will be facilitated by Randy Bowers, who's a meteorologist. The WFO in Norman, Oklahoma had a great presentation last week at the National Weather Association meeting. We are looking for future presenters for the Satellite Book Club, so if someone in your office, maybe you have something to share with us about operationally relevant applications, please feel free to get in touch with us. And if you're looking for training, Brian Mata and the team at the Office of the Chief Learning Officer can provide you with training materials that may be unavailable or just difficult to find. Thank you to the Tower S team, Lee Byerly, David Blutis, the Office of the Chief Learning Officer, the GOES-R program, and JPSS for the support of the Satellite Book Club Seminar Series. Without further ado, I'd like to introduce Mike, who is a physical scientist at NESDIS STAR. He leads a science team focused on utilizing artificial intelligence to transform large volumes of data into actionable information. Systems developed by his team include ProbSevere, the recently available over the SBN fog and low Stratus product, and the VOLCAT toolkit, which I think is going to be a subject of presentation later this year. Dr. Pavolonis also serves as the NESDIS lead for wildfire product planning, coordination, and user engagement. Mike, welcome to the Satellite Book Club.
Oh, thank you, Jordan. Yeah, it's a pleasure to present here. And you know, in terms of ProbSevere, this is an exciting time. So I'm the principal investigator for ProbSevere, but I want to recognize John Centennial, who really does a large part of the hands-on work and manages it from day to day. And so without further ado, I know many are familiar with ProbSevere because it's been around for a while, experimentally and in test beds and such. I'll say more about that in a moment, but just for those that may not be familiar, I'll just quickly summarize what it is. It's a artificial intelligence tool. It utilizes machine learning to bring together NWP data from the rapid refresh model, satellite data from the GOES-R system, and NEXRAD data via the MRMS system, along with lightning data from ground-based networks provided by Earth networks to estimate the probability that a thunderstorm that you can actually see in some form of observational data will produce severe weather in the future, and up to about 90 minutes in the future, typically about up to 60 minutes in the future, but sometimes stretched to 90 minutes in the future. So again, this was making predictions about a storm that actually exists in observational data. So it's not model space storms, it's observation-based storms. And the model produces a new prediction every time a new piece of information comes in. So every 2 minutes we get MRMS or we get lightning, the model updates its predictions. So just a little bit about the history. And so ProbSevere started off, the development started, in earnest around 2010. And what we now refer to as ProbSevere V1, which just estimated the overall probability of severe. We first introduced that to forecasters experimentally, actually in 2013, via a little local experiment we had with the Milwaukee Sullivan office. And then we introduced it via the Hazardous Weather Testbed between 2014 and 2016, each of those 3 years. It was also evaluated at the Operations Proving Ground and WFOs via an experimental data feed through the LDM, which is still available right now. Since 2016, we've moved on to ProbSevere V2, which extends the capabilities of ProbSevere version 1 by not only offering predictions of overall probability of severe, but also probability of the individual hazards, hail, wind, and tornado, as defined by the National Weather Service. Version 2 was evaluated in the Hazardous Weather Testbed the last 3 years that the Hazardous Weather Testbed was conducted. Of course, it wasn't conducted this year because of COVID-19. If you have AWIPS version 19.2.1, which was released, I believe, in July of 2019, then you're able to utilize ProbSevere version 2 and display it in AWIPS properly with all of the capabilities. It's also available experimentally right now via the LDM feed. And the really exciting bit of news here is that it's been in ProbSevere version 2 and version 1, actually, for continuity purposes, have been integrated into the MRMS version 12, which is expected to become operational at NCO in mid-October. So currently it's in a 30-day pre-operational test phase. If the rest of that goes well, then we'll be looking at somewhere around October 14th for the MRMS version 12, along with ProbSevere version 2 to become operational. And you know, we thank our colleagues at NSSL and NWS-MDL for, you know, that collaboration to make this happen. We're getting near the finish line, and that's obviously an exciting thing. Okay, so just to remind everyone what ProbSevere looks like. So you have the display in AWIPS where you can overlay contours of any of the probabilities around NEXRAD data or any other data that you have as a base layer. And then there's a mouse over capability so that what you see here on the left, you can mouse over and get all of the readouts of the different probabilities as well as everything else that went into the model to derive those probabilities. One of the new things with the display that wasn't available with version 1 is the option to do a 2-contour display. And thank you to Lee Krantz for developing this and working with the broader AWIPS team to get this implemented. This allows the user to optionally configure a second outer contour display, where the inner contour is any of the probabilities that you want, whether it's wind, hail, overall probability of severe, and the outer contour option is to display the probability of tornado configured to only appear when a certain threshold is met of probability. So you can set that threshold to be 0, so that it's always displayed, or you could set it to be something greater than 100, so that it's never displayed, or anything in between. And the link here describes how to do that configuration in your AWIPS system. And so this just allows an extra level of situational awareness. Okay, so the one example I'll show here of ProbSevere, this is an animation from AWIPS. This is March 3rd, 2019, showing a domain near the Alabama-Georgia line. This was a very active day with a lot of severe weather, including some significant tornadoes. And so I'm showing this example. You know, one thing that with ProbSevere that we've never advertised it as, it's not really providing you, the forecaster, the expert, with insights that you couldn't derive yourself through interrogation of all of the relevant data, right? It's not smarter than a human, but it does provide some comparable insights. And it does so in a way that's really, really efficient because it's automated and it's a computer system. So what ProbSevere, where it really helps, and this is based off of feedback we've gotten from forecasters over the course of several years, is, you know, when you have very busy situations, it helps with triage, which storms need your attention at a given time. And when you need to make very quick decisions because things are rapidly evolving and very busy, it helps to increase forecaster confidence in terms of a decision. If you're thinking one way and ProbSevere provides guidance that's consistent with your thinking, that helps you to make a warning decision, be more confident in your warning decision. So that's really how this tool is meant to be used. It's not meant to provide information beyond what the human can do. It's just, it integrates data in a very efficient manner that facilitates decision making in a more efficient way and adds confidence. We recognize through feedback over the years that, not just looking at the AWIPS derived or the AWIPS contours over the radar data, but the time series of ProbSevere derived information is also insightful. And Tom Holquist of the SUE at NWS Minneapolis years ago developed a really nice web display tool that allows you to translate a ProbSevere storm object into a time series of not only the probabilities, but a lot of the variables that went into deriving those probabilities. And so there's this nice web-based tool that many of you will be familiar with, but we recognize that's not optimal in the long term. We want to have an AWIPS capability to do this. And so thanks to Lee Krantz, this is just a prototype example, but Lee's done most of the work here, and it's very close to the finish line of having an AWIPS capability to display time series of ProbSevere derived probabilities by just clicking on the storm in a certain way. We don't have the radar data overloaded in this example, but you get the idea that you would click on any of these objects and you can pop up a time series of the probabilities to give you that additional insight into what the trends of the model are, as we've gotten feedback that that's just as important as the probability at a given time. And so we hope to evaluate this time series tool in the 2021 Hazardous Weather Testbed, should that go forward. Verification, a lot of people interested in that with good reason. We have a paper that is now online from Weather and Forecasting, where we've looked at things such as probability detection, false alarm rate, critical success index, as well as the probability threshold that maximizes the critical success index as a function of county warning area. And so if you want to, you're at our WFO and you really want to know what the performance is like in your CWA, you could go to that link below, and we have a version of this that's in a web mapping service. So you can click on different probability thresholds here at the top, and it'll regenerate this map, and you could zoom in on it, and you could click on any of the county warning areas, and you can get the ProbSevere verification statistics for that CWA. So this doesn't include lead time. At this stage, we're working on adding that because that's a really labor-intensive metric for us to derive accurately. We have a student working on that right now, and we hope by the end of the year that we'll add the lead time, the updated lead time statistics to this. Also published in this paper, we summarized the feedback that we got through hazardous weather testbed surveys. So at the end of every day, the forecasters were asked questions, the same questions. And so that we over the course of 3 HWTs, we were able to gather 232 responses that were consisted of 68 different forecasters. And so this is just highlighting some of those. So this is the probability of yes, or not the probability, the percentage of yes forecasts. Did ProbSevere increase your confidence in warning decisions? You can see the positive responses there are high. Did it help increase your lead time? Again, most forecasters thought that was the case. And then we asked about probability of tornado specifically, and those same two questions. And you can see that generally it increased confidence, especially in 2018 and 2019, where we had an improved version of it. In terms of lead time, a little less conclusive there about whether or not it was adding lead time. Okay, so that's ProbSevere version 2, which we're excited that is going to be going in operations, but we're also looking forward to what the next generation will look like. And one of the areas that we identified, can be improved is our utilization of satellite data. Particularly the ABI and GLM. GLM is not currently used in ProbSevere, ABI is, but we're only, sort of just hitting the tip of the iceberg on that. And so we're looking at ways to do that better. And so one way we think about this is, how can we quantify the eye candy, right? I mean, there's all these countless beautiful ABI images, and you could overlay GLM fields on top of it, where humans can see all sorts of indicators of storm intensity and precursors of severe weather, such as robust overshooting tops, above anvil plumes, thermal couplets. those are things that the human expert can see well, but have been elusive to quantify. But now that advanced machine learning techniques such as convolutional neural networks are easier to build and implement than they ever have been, those are ideal for attacking a computer vision problem like this. And so what we've done is we've built one of those convolutional neural networks to take ABI and GLM images and determine the probability of intense or severe convection. Intense meaning sort of precursors to severe, and then severe actually in a severe state. Why would we want to do this? We want to increase the lead time of these nowcasts, and we want to do better in the absence of radar data, because radar coverage is not uniform everywhere and doesn't exist in some places, of course. So this is so these contours here over the top are the probabilities of intense convection derived from this model, just overlaid over the sandwich product of the VIS IR. And the magenta is greater than 90%, the cyan is 50%. So what I'll just show here in an animation of 1 minute GOES data, GOES ABI data, I'll show you these probabilities evolve for just a one time period here, just to give you a sense. So what you see is that the coherent maxima of probability reflected by those contours generally appears well in advance of severe weather reports, indicated by the different colored circles that appear. And the results are typically consistent with how a human would assess this. This works both day and night. We take advantage of the half-kilometer VIS during the day, but when it's not available at night, this can run on infrared and GLM data alone. So we're excited about this. There's actually a paper that is in review right now on this, and you'll be hearing more probably in the future about this particular tool. Okay. I'm not going to go through this, but I wanted to add links to different resources that are out there. So that's there for the record. And so just to wrap up before we go into discussion here. So ProbSevere V2 versus V1. V2 offers hazard-specific probabilities. It also, where it improves upon version 1 the greatest, we think, is in improved prediction of wind events. ProbSevere version 1 tended to struggle with those. Version 2 does better. There are, of course, limitations that remain. We didn't list all of them here, but two primary ones I'll call your attention to are, underestimating the probability in lightning-poor storms that produce severe weather, and underestimating tornado probability in advance of weak tornadoes. That is a major challenge. And so the thought I'll end with here are that, AI tools like ProbSevere, they are becoming more advanced and they're becoming more reliable. You're not seeing all of that quite yet because there's a big time lag between what's in the research realm and what gets into the operational realm. We call that the valley of death. But there are tools that cross that valley, and more of them will. So in response to this, just thinking about how operational workflows may evolve, I think that makes for an interesting discussion. And with that, that's all I have for the moment.
All right, thanks, Mike. That was excellent. Great summary. I think there are some key points really worth kind of revisiting or reemphasizing there from what you said about how, the system isn't smarter than the human, but it's very, very efficient. And efficiency in managing data flow is very, very important in operations. So, there's maybe that's something that we can talk a little bit more about in the discussion. But I would certainly encourage anybody else that has any questions, feel free to add that into chat and we can get to those as time permits. But just kind of leading off here a little bit and along the lines of what I was saying, I'm curious, Mike, or anybody else, if you have any thoughts about kind of where the role of the human will be, with these type tools, AI, machine learning, ProbSevere, maybe, how the forecaster really can coexist and thrive in that environment with all these new tools such as ProbSevere coming along. It's kind of a general question, but I'm curious if anybody has any thoughts on that.
Well, I'll just quickly offer my thoughts. I'm not an operational forecaster, so I'm really interested in what the operational folks, how they view this. But the thing that we'll have to keep in mind is that these tools are not going to go away. They're going to continue to evolve. And so, completely ignoring them, an organization will fall behind and become less relevant. completely investing in them and getting away from humans too quickly is also a major mistake. There's something that lies in the middle there. And, I think what it is utilize these tools as the big integrator of all these environmental data sets that are just growing in volume, becoming too large for humans to interrogate manually all the time. And then what that does is it frees up the humans to do things that are uniquely human. Communicating hazards, working with core partners, doing things you would never ever want a machine to do. So I think that's kind of how these things get phased in, is not automatically issuing warnings. That's still the human's job, but just making that more efficient and allowing the humans to spend more time doing the things that they can uniquely do and machines cannot.
Yeah, I think that's excellent, Mike. And things such as artifacts and radar, three-body scatter spike, side lobe, bounded weak echo regions, alias velocity, things like that. Humans are going to be probably superior for quite some time with that too. So even from the analysis standpoint, it seems like that there's kind of a role to use the guidance, to see the trends. I really like those trend plots that look like it's coming with the new version there. And then from there, the human forecaster can kind of nudge one way or another. But would be in a much better situation as far from situational awareness of what ProbSevere can give. So I'm excited about it. I've really tried to wrap my head around it. I had some good conversations with other forecasters and other people in the agency, and it's really fascinating to me. I just think it's a really important conversation to have about this data management, and then being able to sort of maximize the human for what they can provide that's beyond what machine learning and AI can at this point. So there are a few other questions in there too. I think Jim Ledoux was asking about a link to the paper for the CWA study. I believe that's in chat now, so you may reference that, Jim. Just kind of looking through some other questions here. There was a question about GLM data and how that's integrated, and yeah, it looks like that's certainly available in some of the newer versions of ProbSevere as well. That's an important part of it. Just looking through here just to see if there's anything else as well. One other question, I was kind of interested just to kind of maybe talk about where we will be in 5 years from now. We're starting to see more and more forecasters use ProbSevere now, but say 5 years from now, what advancements do we hope to see? I know you covered that to a certain degree, but where do you see ProbSevere being in say 5 or 10 years?
Yeah, good question. So, I think we'll continue to take better advantage of the more advanced machine learning techniques that are out there, and including the ones that are designed for computer vision problems, like the nuanced interpretation of ABI satellite imagery within the context of GLM derived lightning fields. So we've made good progress on that. So I think you'll see lead times or increase. I think you'll see skill increase. And the other thing is, one thing ProbSevere doesn't do right now, it doesn't tell you where the storm is going to be when it produces severe weather. It just tells you, okay, here it is right now, and within a certain window of time, there's a higher probability of certain types of severe weather. So I think taking advantage of the tracking information that we already have to maybe look at deriving probability cones akin to what was done in the PHI experiment within the experimental warning prediction program. Again, not automating these warnings and sending them out. The human's still going to do that, but just taking that, taking it to the next logical level of providing that type of information. So, I think these environmental data sets and both in terms of observations and NWP are still pretty there's still a lot to be tapped. We know there's going to be advances in storm scale modeling. How that fits in here will be an interesting thing to think about, but there's a lot of possibilities.
Excellent. I see a question in there about RAP as a background model field. Is it, I guess, part of ProbSevere, or does any model data, I guess, as a background field, is that included in the ProbSevere?
Yes, absolutely. We use several fields from the rapid refresh model. If you go to the link on training, which is in the slide with all the links I showed, you can get a full listing of what we utilize in the model. it's a bunch of things, so I won't rattle them off here. But yes, we do. ProbSevere does take into account the background thermodynamic and dynamic conditions. We're looking at changing over to the HER at some point, but that'll be probably give us incremental improvements. I wouldn't expect there to be a huge jump in capability because of that, but it'll help incrementally.
Okay, there was also a question in here by Brian Mata about GLM and specifically which GLM data or grids may be included, events, groups, flashes, some other things in there. Can you talk more about how GLM is integrated or may be integrated in the future with ProbSevere?
So right now our use of GLM is confined to the convolutional neural network that predicts intense/severe convection. And from the GLM, we're using the flash extent density. So it's one of the graded products that we're using. So we're using the GLM tool software to generate that. And we found, that captures the essence of the GLM information as well as anything after a bunch of experimenting. So for this particular application, we found that was the best thing to utilize. And the nice thing about the convolutional neural network is that it's looking at things spatially. And so that's where the GLM is really offering unique information. It's a mapper. It's mapping out the lightning. Yes, it's fairly coarse resolution, but that's unique relative to what you can get from the ground-based sensors. And so a convolutional neural network is going to be the type of tool that will help get at those nuanced spatial patterns and really take advantage of that, the space-based observational capability.
Excellent. I don't want to run over too much. I know Jordan probably has some closing comments, but there's one question here I thought was really important, and I've wondered this as well, that's talking about cell mergers and splits and how that's very important in severe weather forecasting from James Frederick to ask that question. I guess if you can maybe briefly comment on that, and then we can turn it over to Jordan, and then maybe we can kind of stick around a little bit more for once we kind of make some closing comments for people that need to jump off, and then maybe have some more discussion. But if you want to kind of briefly touch on this challenge with cell mergers and splits, that may be really good for the audience.
Okay, sure. Yeah, I'm happy to stick around. So that is a major challenge. We're utilizing an automatic storm identification and tracking algorithm via the WIDS2 package, and those automated methods will not always agree with the human assessment of splits and mergers. And because of that, you can get artifacts and probabilities. For mergers, you can get, sort of spikes in probability that maybe are not ideal. And for mergers, you can see, artifacts, drops in probabilities, things like that. So it's, we're always trying to improve that, but those improvements will probably be just sort of incremental over time.
Sounds good. I could go on and on. Maybe we can continue to have a little bit of discussion. But Jordan, do you want to kind of take over from here and make maybe some final comments?
Yeah, I appreciate that. I realize there's a few people that have to run, so we like to wrap it up at the bottom of the hour, but I think we'll continue on after this formal wrap up for about an additional 15 minutes if the attendees want to stick around. It sounds like you and Mike are both available to do that. So just wrapping up here for those of you that do have to head off, we are looking for your feedback on this. So there's a link in the chat, or there will be one soon, that you can click on to fill out a short survey. Next week, Thursday, October 1st at 12 noon, we're going to have Warren Blyer, the SU at the WFO in Monterey. He's going to present on the use of geostationary and polar orbiting satellite data for coastal California dry season weather forecasting. So look for an email on that from the Tower S team. Just as a reminder, hopefully your office is making progress installing the Tower S RPM version 19, or configuring if you need help configuring any of the latest satellite products, and that includes the FLS, contact John Evans and Lee Byerly. That team is standing by. So their contact information is up there on the screen. Other than that, for those of you that have to head out, I hope everybody is staying well and things are going okay. We'll turn it back over to Mike and Randy to continue the discussion. Thanks.
All right, thanks everyone for those sticking around. I guess we've got a few more questions in here. Somebody was asking about, let's see here, the ProbSevere ingredients that contribute to alerts under different situations. So I guess maybe that sort of ties in with, and I kind of had a little bit of a question with this too about maybe dynamic weighting and things. So you may have a different situation, a different environment. You're focusing on something that's, maybe you're really focusing on something that's a little bit different, I guess, in one environment versus the other. Is there any sort of dynamic weighting with this, or is that something that may be considered in the future where, say, maybe GLM data or cloud top cooling may be factored in more? And then in other situations, there may be, the model could recognize, I guess, that there would be a need to focus in on other parameters. Does that make sense?
Yeah, that does, absolutely. And so the way we handle that is actually the probability of hail, the probability of wind, and the probability of tornado are actually derived from 3 separate models, each model customized to the ingredients that are most pertinent to making those predictions. So for hail, obviously, mesh is a huge observational driver. For wind, there are different NWP parameters that we need to take advantage of to get out, downburst events and things like that. So yeah, in the training module, we outline how those different models are, what ingredients go into them, and that gives you a sense as to how we approach it. So the development of the model was very much based off of physical understanding to the extent that we have it of how these different severe weather events unfold, and that influenced the ingredients that went into each of those models, and we just aggregate them all together at the end. So that's how we do the weighting, is by having separate models.
Okay, excellent. Yeah, a few more questions coming in here. Also, Dr. Ravier, with the ECMWF director, was asking about, all the emphasis, I guess, in NWA, talking about AI and machine learning as an important part of the future. Is there any thought, I guess, towards maybe this becoming in the future at some point more than a second opinion? I mean, I guess maybe this is way down the road, or kind of maybe some way that it may evolve even beyond kind of what we're thinking now, for it to be sort of this foundation of information that we then act on, but maybe become even something more than that?
I mean, one analog to look at is how the use of NWP has evolved in operational forecast products over the years, right? Now, there's a lot more automation, and then sort of humans making the tweaks than there were, many years ago when I first became familiar with how some WFO forecasts are generated. And so, I think like everything, as the comfort level goes up and as the tools get better, there will be a very gradual shift to relying on it a little bit more than just for the situational awareness, second opinion type of thing. But it's going to be very gradual. It's not going to be a light switch, and you won't notice it. It'll be hard to notice because it's going to happen, I think, very gradually over time. But do I see machines performing all the operations of WFOs anytime soon? No, not at all. But do I see the humans spending more time on communication of information and hazards than on, digging through piles of data? Yeah, I do see that.
Yeah, that makes perfect sense. We've talked before about when the machine can do that, you can see trends in it. It can look at large amounts of data, many inputs. Why would we as humans spend the time digging through all these different inputs and looking at trends when we can just be targeting our base data analysis and applying our conceptual models? It makes total sense to me, really. And I guess along those lines too, I kind of was curious about this. I know there was one talk at NWA in the context of machine learning and AI that I found really interesting, and I wish I could remember the presenter and specifically what he said, so I'll have to paraphrase a little bit, but he talked about these rare events, and not just in meteorology, but in other aspects of machine learning and AI, about how these rare events are sometimes the biggest challenge for AI and machine learning. So I'm curious maybe your perspective on that, about how maybe some of the more outlier events that we deal with, that there may be a little bit of a struggle where the human can possibly recognize a little bit more.
Yeah, that's a very good point. That is an ongoing challenge for these methods. There are certain ways to deal with that. The more data that you give to a model, the more it'll understand things that are more rare. So, there are ways to reinforce the knowledge of these models over time, so that becomes less and less likely. But again, that's one of those things where I think a more gradual shift to reliance on these things will help, that'll help us better understand what the limitations will be in the long run there. Yeah, I mean, in terms of the severe weather problem that the ProbSevere is tackling, we haven't seen extreme storm behavior that, where ProbSevere hasn't produced a high probability, in terms of the core hazards, wind, tornado, and hail. But, we do have to be mindful of that in many of these applications that utilize machine learning.
Yeah, and these are the same problems that, even the human sometimes can struggle to recognize these outlier events too. So it's a problem for both machine learning and AI and the human forecaster. It seems like one good example I can think of off the top of my head is maybe the left splits, where sometimes the reflectivity profiles and typical thresholds may not quite be there for hail that would be of severe size or larger, but yet, both the human may have a little bit of a hard time recognizing that, but especially maybe something like a model that's well calibrated may struggle just a little bit with that too. So that's just one thought I had that popped to my mind. Now, Steve Cobb in Tulsa, he was asking about the place files for GR analyst and was asking about, I guess, when the move happens to NCO operations, will those still be available?
Yeah, certainly for the near term. One thing that I did want to mention is that right now there is no plan to archive ProbSevere data generated at NCO, just as there's no long-term archive for MRMS either. So if there is a need for that, that requirement needs to be changed, then we need that to come from the users and be user driven. They're not going to listen to the development team on that. So I'll just put out, if there's a need, if there's compelling reason to have an archive of ProbSevere, we should make sure that gets passed along so that there's some momentum to change those requirements. But in the near term, we'll continue to have the GR place files available through our web mapping service, but that'll be a parallel service to what's in NCO. How long we keep that going, I don't know. It'll depend on what resources we have and other things.
Okay, excellent. Yeah, I think there was another comment, I may have skipped past it up there, that did ask about archives and maybe doing some studies, local studies, that sort of thing too. So that may be something to kind of keep in mind from an archive standpoint. At least if nothing else, there seems to be people that are certainly interested in going back and looking at how maybe this performed with certain events that they've had in their past. I know I would certainly be interested in going back and look at some of our events too, that kind of how ProbSevere performed with that. I'm just looking through here. I don't know if anybody else has any questions. Feel free to add them to the chat. I don't know if I'm just trying to see if I've missed anything in here. There was a comment about experience at early to late season, low top convection with little lightning and in a high shear environment. Can certainly be a challenge with algorithms at times. Matthew Clay kind of made that comment, so it's really that's a good point. I mean, sometimes the convective evolution may not really be able to benefit from the input from things like GLM, for example, from lightning data, because it's just a different environment. So I wonder how that would play into it. How much reliance is there on, say, GLM and lightning data in such a situation that if it is highly sheared, that maybe the model may struggle because it doesn't have that lightning input? Does that make sense?
Yeah. So one of the caveats I pointed out on the summary slide was exactly this type of scenario. And so lightning data, it's a fantastic source for severe weather prediction, but it has limitations. Not every storm that produces significant weather is going to have a lot of lightning, and not every lightning jumps, and the correlation between that and severe weather is complicated. It's not a straight line either, is what we found. So yeah. We utilize lightning within the context of the shear to try to minimize this, but there are still scenarios where the lightning is so low that the model won't perform well there, and I don't know how we solve that. We'll have to see, but yeah, definitely Matthew Clay's point is, that's right on.
Yeah, and also I guess Steve was talking too about, and this kind of reminds me too, we had a couple scenarios that we had that we would go through from sort of a training environment in our office. And we weren't able to incorporate ProbSevere in the WES simulations for these, and so it's not currently available in the WES. I don't know the technical reasons for that, or kind of what maybe we need to do on our end of the Weather Service to make that happen to where we can have that. It seems like I remember some discussion from Alex, one of our forecasters that's extremely knowledgeable in the West, about maybe in the future versions that will become something that we can integrate. But this is such an important tool. I think that it needs to be integrated in the training environment like that. So if there's a way that we can get that into the West, I don't know if anybody here has any answers on that, but it's certainly something we need to try to push forward with to make sure that we have that in our training environment.
Yeah, I'll just say that the science team, we support doing that, but it really will be up to our colleagues in the training part of the problem to help us or to initiate that and help move that along. We're happy to help where we're needed, but to support that. But and to Brian Motta's point in the chat about ProbSevere and the NESDIS cloud, ProbSevere is going to be operational at NCO, not at NESDIS. So this is not a NESDIS R2O transition. It's an NWS. So it will not be a part of the NESDIS cloud.
Yeah, and then Andrew Shashi said, also kind of added to Matthew Clay's point about these high shear environments where you may not have a lot of lightning at all, but in a tropical situation you see that a lot of times, and the tornadoes that occur with that, maybe that's an area where the probabilities may have been a little bit low. Certainly a thing that we can maybe add value with, at least with the current state of ProbSevere. In the future, hopefully that can kind of evolve some. But yeah, excellent points. See a lot of points coming across in here. Good comments, good questions.
Yeah, ProbSevere was not specifically trained to target landfalling tropical systems. So that would have to be a special point of emphasis to go after those. But I think some of the work we're doing with convolutional neural networks, and that may help there.
Yeah, really cool stuff. Just kind of a broad comment I was thinking of too, to maybe kind of just add to the conversation a little bit is, I think that forecasters struggle with black boxes some. So I think that now that we have the readouts that can show the specific values, I think that really helps. At least it did for me. To me, it no longer was a black box where I didn't understand where this was coming from, what it was doing. And now I understand a lot more about it too, after having some conversations with Chad Gravel and others about really what the purpose is. And I think this summarizes it very well about talking about how its purpose is to make the process more efficient for forecasters. But things like the readouts, these trends, these graphs, these probabilities, I think that's very, very important, and that's going to be very important for having the forecasters embrace this going forward. Now, I can speak from my colleagues and other people I know in the Weather Service. I don't think there's necessarily an issue with sort of not embracing some of these new technologies as much. I mean, there may be some skepticism on the front end until they understand how to work them into their workflow. That's probably the biggest thing. But I think most forecasters are very open to sort of integrating these new tools and being able to kind of figure out where they can be of most value, and they can really focus their analysis instead of it being this broad thing that they have to keep stabbing at, all these different parameters and new high resolution data that we can then kind of narrow it down and focus on base data analysis, QC of data from radar data and whatnot, and then be able to kind of use that intelligence to nudge either way if we need to with this statistically calibrated guidance. So that's just my thoughts, just kind of going forward there. And I don't know if you want to add any more to that, but I don't think can be emphasized enough what you were saying earlier about how this really isn't necessarily smarter than the human. It's just meant to be a really good tool for us to use.
Right. Yep. No, I appreciate those points. Yeah, I agree. Most users we encountered are open to new tools like this. And we've always emphasized that it's not a replacement. It's a tool to help you do your job more efficiently. So, it's a bit of a gateway AI, right? Because it's a simple enough model that you can understand through the readout in most scenarios why it's giving you the answer it is. As it go to more sophisticated AI, it does become more of a black box. And so, I think one way to integrate AI into NWS operations is through systems that are more readily interpretable, like ProbSevere, and then build up, confidence and familiarity, and then you start bringing together the more advanced tools where, much like an NWP model, you can't diagnose how it got its answer. It's too complicated. You just have to, have some trust that the guidance is generally useful.
Yeah, absolutely. This is great discussion. I definitely appreciate it, Mike. I don't know if we want to keep going here. There was a comment that was kind of asking about ProbSevere, what reasons there may or may not be for archiving that, and again, I think we talked about it earlier too, especially I can just speak a little bit from the Weather Service standpoint. If we were able to integrate that into the WES and be able to fully integrate that into part of the training environment that we're sort of used to being in the WES, I think that would be very important, because then we could certainly show the value, I think, more in sort of a more relaxed environment instead of on the fly in operation. So just like any tool, if you want to try to integrate it, if we can bring it into the WES and we can kind of get the forecasters in that environment to understand what value it has, it's certainly very important, I think, going forward. So I don't know at this point, I don't know if Jordan has any additional comments, or Mike, if you have any closing thoughts or anything going forward.
I'll just say, until there's a WES capability, we can continue to help out by providing place files for GR analysts. We've done that a lot for a lot of WFOs to help them with case studies and training. We can't do it for every WFO if we got crushed with requests, but if there are some requests out there, we can handle some of them.
Excellent. And David Glenn kind of added that point to say that the postmortems for these extreme or atypical events, that's probably pretty important too, to kind of go back and look at that just to see see where maybe some of the weaknesses are and understand that from a forecasting standpoint. So really good stuff there. Well, I think that's everything. I don't know if anybody else had anything to close with there, but really love the discussion. Really appreciate that, Mike, and I appreciate the opportunity to be a part of this discussion too and help facilitate.
Thank you, Randy.
Yeah, thank you so much, Randy. Thank you, Mike. Really appreciate this. I think this was constructive, and look forward to the future of ProbSevere. I already wrapped up with the formal conclusion, so I'll just remind everybody your feedback is solicited, and please join us next week at the same time, same place, for another great presentation. So thanks everybody for your time today. Stay well and take care.
Thanks.